Hi guys, so here we go. We've got the 1-2 notes. So 1-2 is about functions. What are functions? What are inverses and how do you find them? And then graphing adjustments. Okay, so we've got a quick 4 definitions up here at the top. So this should be review for you. A relation is just any set of ordered pairs. Basically, if you have an input, there is an output. Okay, so a function goes slightly further with that idea and making sure that the input can only yield one single output. Okay, so you can't have, like, if I put a function of 2 in, it's not going to give me more than one output. Okay, so that directly relates to the vertical line test. You can't have 2 points that are on top of each other, otherwise it's not a function. Okay. Do remember the domain is simply your x values and your range is simply your y values. Okay, so that should be a review for you. So if we take this and decide for question number 1, if this particular piece right here is a function, x plus y equals 1. So what do you think? There's kind of 2 ways to think about this. You could say, oh, well, if I set this equal to y, that would be simply negative x plus 1, that would be a linear function. And I did say the word function. It is linear and does pass the vertical line test, so yes, that would definitely be a function. Okay, moving on to question number 2. We've got a beautiful little circle, and I hope you all said heck no to that one. That does not pass the vertical line test. Okay, moving on to question number 3. At 3, we have a quadratic, and particularly a negative quadratic, which is an upside down parabola. Okay, that would be, yes, a function. Okay, so now when we get to question number 4, you see something kind of interesting. You have a y squared. Okay, so does anybody remember what a y squared does? Okay, you can think of it 2 ways. If I solve for y, you'd basically have to take a square root, which means you would have a plus or minus, which yields 2 separate equations. This is going to produce a parabola, but not just a parabola particularly on its side, and it would be technically moved to the right 1 unit. Okay, so this does not pass the vertical line test. So this is a no. Okay, so a very simple way to remember if something is a function is just looking at the type of function it is, thinking about its graph. If you see an exponent on a y, basically it does exactly the same thing as if it was turned on or to the x, but it just simply turns it on its side. So it's possible for you to have something like x plus y cubed to be a function if it's a John Travolta on its side, but it depends on the wiggle. Right? So if we have a wiggle like this, that would definitely be a no. But if it's a quick wiggle where it's more like so, that could be a potential yes. Okay, so you have to be careful about odd exponents on your y for your vertical line test. So playing it safe is just simply solve for y. Okay. The next set here is just working with functions. Okay, so we've got f of 10, so all I would simply do for f of 10 is take the value of 10 and plug it into the x value of my f of x. So I can say f of 10 is 3 times 10 minus 1. So I hope you got to 30 minus 1 is equal to 29. Okay, number 6, we've got g of x plus the change of x. So we're going to plug x plus the change of x into the x of our g function. So this is going to turn into x plus the change of x is equal to x plus the change of x squared. Okay, and technically I can leave it like that and be done. That is okay to leave it in factored form. If you did decide you wanted to FOIL that out, you could, and that would become x squared plus 2x change of x plus the change of x squared. Okay, So you could write it either way. Both are simplified completely. Okay, so number 7, this is kind of getting squished together here. You see g of f of x. So for this one, we are going to take the f and plug it into the g. Okay, so take the f piece and plug it into the variable of the x. Okay, so this will look like, I'm going to write this number over here. It's going to look like, so I'm writing my notation. Okay, and be sure, guys, that you are writing your notation along with this. Don't just write this piece right here. You have to write the notation. When you get to the free response questions of the AP test, they're going to require that you write this piece out. Okay, otherwise it's incomplete information. Okay, so you have to say this is equal to, and now we're going to plug it in, so it's going to be 3x minus 1 squared. Okay, so again, I can leave it in factor form, or if I'm feeling like doing some more work, I could FOIL that out and get, let's see, 9x squared minus 6x plus 1 if you use that factoring model. Okay, so either way, we could FOIL it. Okay, and number 8, another composition. Okay, so we got fog, so remember that the second one goes into the first, just like the previous, so we're going to plug the g piece into the x of our f, so we're going the other way. So our notation is the fog of x is equal to, we're plugging this in, so we're going to have 3, plugging in x squared minus 1. And there's nothing we can do to simplify that piece, so we're going to call that quits there. Okay, so that also should be reviewed. Pretty simple, pretty straightforward. Unless you have a change of x, then it gets a little bit ugly looking, but otherwise straightforward. Okay, so let's practice a little bit with domain and range. Okay, so we're asked to simply find the domain and range of each of these functions. Let's start with number 9. So if you recall, for domain, there's 2 ways in which you can restrict the domain. Okay, so I don't know if you want to write this down somewhere. The 2 ways to restrict the domain. One way, restrict domain, is to have a negative in the radical, right? Negative in the radical. Okay, so you can never have a radical that is negative. So basically anything that's inside a square root or any even numbered root has to be a positive value. Okay, what's the second way? The second way is, what can you never do? Divide by 0. So 0 in the denominator. Okay, I'm abbreviating that, so make sure that when you write that in your notes, it makes sense to you. All right, so for question number 9, this is our negative radical. You cannot have a negative radical. So if I take the inside, x minus 1, and simply set it greater than or equal to 0, that will tell me what the domain will be. So if I solve this, I'm just going to add 1. That tells me the values that x can be. Okay, so my domain is going to be x has to be greater than or equal to 1. Okay, now for my range, I think it's kind of best to graph this. And hopefully you kind of remember what this looks like. If not, type it in your calculator and take a look. Okay, when you graph this function, you should see basically the sideways parabola, but the top half. If you have a minus 1 inside with the x, what direction is it going to move? It's going to move to the right. So you're going to have a top half that's moved to the right, something like that. Okay. So if I'm thinking about the range, the y values, what is the smallest value that y can be to the biggest value that y can be? Okay, so thinking up and down, the lowest is going to be at 0, and then it continues upward. Whoops. There we go. Okay, so my range is going to be y's got to be greater than or equal to 0. Okay. All right, for number 10, domain. Okay, well, do I have a restriction? Is there a radical involved? No, but we have a denominator with an x. So what is the one value that makes this function undefined? Hopefully you just said 2. Okay, so we would say the x cannot be 2. So domain is strictly x can't be 2. Okay, now for the range, we would graph this. Okay, so this is kind of that hourglass look again. Go ahead and type it into your calculator if you feel like you want to do that. Minus 2 is going to be shifting this function to the right 2. So we kind of have vertical asymptotes. Let's move there, and then we have a horizontal asymptote bigger on bottom. Okay, so we got this, and we'll go over graphing these again, so don't be too worried if you don't remember this, at least not yet. Okay, so think about what your range is. That there's a horizontal asymptote involved. Where was that horizontal asymptote? Right there on the y-axis, or excuse me, the x-axis. Okay, so what's the one value that the y will never be? It will never be 0. Okay, so hopefully you can remember the different ways to find horizontal asymptotes. If not, trace it on your graphing calculator. And again, I will cover that concept again, so don't freak out yet. Okay. All right, number 11. So now we're working with this graph that's given to us. Okay, so it's a little bit hard to tell, but this is the y-axis right here. This is the x-axis. So there does exist a vertical asymptote right on the y-axis, so it's hard to tell, and a vertical asymptote right at 2. Okay, so if I have 2 vertical asymptotes, that's a restriction on the domain. So that means that x cannot be 0 or 2. Okay, and the range from this graph, remember this is y value, so you're thinking from the smallest to the biggest. So it looks like to me that it goes down to negative infinity and levels out at 0. So I would say, I'm going to put this in interval notation. If you want, you could put it in inequality. It's up to you. I'm going to go from negative infinity to 0. And it looks like it's a horizontal asymptote. So I would say it does not ever touch 0. And then there's kind of a space between this parabola and that 0. So I think it minimizes at 1. And I would say that it definitely looks like it hits 1, so I'm going to say that it's going to include 1 and then go up to infinity. Okay, so if you wrote that in inequality notation, by the way, you could say, range, we're talking about the y, so you could say y has got to be less than 0, or y has got to be greater than or equal to 1. Okay, so either of those would work. Okay. All right, so the last piece we're going to hit today is working with inverses and one-to-one. Okay, so this idea of a one-to-one function is directly related to inverses. Okay, so this definition says one-to-one function, a function in which not only is there, sorry, I can't read, let me try again, a function in which not only is there only one y for each x, but there's only one x for each y, which means it's going to pass the horizontal line test as well as the vertical. Okay, so horizontal line test, so like coming back up here to this little graph up here, would this right here pass the horizontal line test? Okay, it would not because of this parabola right here. Okay, which means if it's not a one-to-one function, then the inverse is not a function. Okay, or you would have to put restrictions upon its domain. Okay, so you guys remember how to find the inverse. I'm taking that as a yes since I'm not there. I'll just assume you do. If you don't, I'll remind you that all you simply do is you switch the x and the y and then solve for y. Okay, so here is the notation, by the way, if you cannot remember that. Okay, it has a little exponential -1, okay, which signifies that you're referring to the inverse. Okay, so this is kind of an interesting thing to read. So the inverse of f is this, oh, that's the symbol, okay, so only one-to-one functions have inverse functions. Only one-to-one functions have inverse functions. Very interesting, okay? So that means if it doesn't pass the horizontal line test, then it does not have an inverse. Since x and y are switched, to positive inverse functions, the domain is switched. Okay, same thing with the range. Okay, so that's kind of cool that all you have to do to find the domain and range of an inverse function is just simply switch the domain and the range. Very simple. Okay, so number 12 says, which of the relations in 1 through 4 is a function with an inverse? Okay, so which of these has an inverse? So going back here, I even kind of drew these out. Okay, so remember number 1, this was linear, has a negative slope, so it's something like so. So that passes the vertical line test. Does it pass the horizontal line test? Yes. Okay, so number 1 is a one-to-one function. Definitely. Okay, what about number 2? Number 2 is this one a function? Not even a function, so we can't even consider the inverse to be a function. We don't even care. So no. What about number 3? Okay, number 3 is a function, passes the vertical line test, but does it pass the horizontal line test? No, it does not pass the horizontal line test. So this is not a one-to-one function. And number 4, not a function originally, so again, we don't care that it's anything about the inverse at this point. So only number 1 is a one-to-one function. Number 1. Cool, okay. So let's practice finding the inverse. So question 13, how do you find the inverse? Okay, so all we're going to do is switch the x and the y and solve for y. So remember, f of x is a fancy way of saying y, so we're going to say x is equal to 2y cubed minus 1. Okay, so all we're going to do is take this, we're going to solve for the y. So what would you do first? You add 1, so I'm going to x plus 1 is equal to 2y cubed. Then you would divide by 2. Okay, and lastly, so we have, I'm going to switch the order of this if you don't mind, we got y cubed is equal to x plus 1 over 2. Last step, cube root it. Okay. Now right now we're going to leave it like this, the cube root, even though it is technically unsimplified. But when we play with inverses, for the most part, we're not going to practice simplifying to a big extent. We're just going to leave it at this point. Okay. But do realize that this is technically not simplified. We can't leave a fraction inside a radical. You'd have to take the radical at the top, the bottom. You can't leave a radical in the bottom, so you'd have to get rid of it. But we're not practicing that right now. We're just working on finding inverses. Okay, so I think that's as far as I'm going to go today. Okay, so what I want you guys to do for homework, we're just going to pause at that spot. Sorry about the bell. And I want you guys to go to 20. So I want you to go 1 through 20 for tomorrow. Okay, and we'll pick up here with the piecewise functions tomorrow.